States of matter. Our performance expectations and objective. You're going to learn how to develop models to describe the atomic composition of simple molecules and extended structures. Students can identify the 4 states of matter, evaluate the characteristics of each state of matter. So I want you to take a look at this picture. We have a rock and we have a bell. I want you to identify 3 differences between the objects that you can see in this photo. Again, the rock and the bell are the 2 things that you are comparing. Please make sure you write your differences on this slide in your notebook. Begin. Okay, so let's take a look at the rock and the bell. One of the first things that you probably were able to observe that's different about the 2 is that the bell is nice and shiny and the rock is kind of dull in color. That's one difference. Another difference you might have noticed is that the bell is made out of metal and the rock is not made out of metal. And the third thing that you probably have noticed about this is that the bell is hollow on the inside and the rock is not. And these are things that you could observe just by looking at them. So now let's go ahead and continue on with our notes. There are 4 states of matter, and we're going to look at all 4 of them and look at their characteristics individually. So the first state is a gas. The second is a liquid. Third is a solid. And fourth is plasma. Now these are 4 states of matter. We're mainly going to be dealing with gas, liquid, and a solid, but I thought I would give you some information about plasma as well. Here you can see that a gas is some sort of vapor or some sort of free-flowing cloud within the atmosphere or within a structure. We also know that a liquid is something such as water. It's not, it's kind of free-flowing, it's easy to bend or to split. We have a solid, and solids, you know, are very rigid and can take a lot to break them. And the last one is plasma. And plasma has things to do with particles and electricity, and we'll look at that a little bit closer. At any point during the slides, if you need to pause this presentation, you can and take your notes, but please make sure you take your notes. Let's continue on. So the first one we're going to look at is going to be gas. Gases are not rigid, meaning they don't have a stiff structure to them. They're easily bent, they're easily cut, and they're easily malleable, or another way, it's easy to kind of conform them into any container or shape. There is no fixed shape for gases. Gases will take the shape, and we've heard this before, will take the shape of any container that they're in. It doesn't matter the shape. They will fill up any shape that they're in. They have no fixed volume, Meaning, if I have this container and I take the cork out of it and the air goes and the gas inside goes out into the atmosphere, the volume is not going to stay the same. It's going to start attracting it to the other gases that are out there, and its volume will change. The particles are well separated with no regular arrangement. So if we take a look at this picture, you can see the particles that make up this gas. They're not in any kind of order. They're not in any columns. They're not in any rows. They're just kind of all over the place. And if you can see, they are spaced out quite far from each other. So there is no rigidness to them. There's no real shape to them because of the fact that they are separated so far and they have no arrangement. Examples of gas, we have helium, oxygen, and air. Again, if you need to stop this so you can take the notes, you are more than welcome to. The next state of matter that we are going to look at is liquid. Liquids are not rigid, meaning it doesn't take a lot for us to bend them. They won't break, so they're not rigid. They have no fixed shape either. The liquids usually will fill up whatever space there is in the container that they're in. But like gas has no fixed volume, liquids have a fixed volume. If you have 10 milliliters of water, if you pour that water out of its container, it will still have 10 milliliters of water. So it does have a fixed volume. Particles are close together. So if you take a look, these particles are really close together. They're not quite touching, but they are really close together. There is no regular arrangement, and that means that they're not in rows and columns. If you see, they're all kind of in here. They're closer together than gas, but there's no definite structure. Because they are not touching each other so closely and they're not packed tight, the particles can move around, and that makes it to where the liquid is able to take the shape of any container that it's in. Examples of liquids, we have water, honey, shampoo. These are all types of liquids. Again, if you need to pause to take your notes, please do. Now we're going to take a look at solids. And solids are a lot different than gases and liquids. Solids are rigid, meaning they are able to break. If you were to try and bend them, they would definitely break. Some will stretch a little bit more, but eventually they would break. They have a fixed shape. A rock is a rock. That rock, if it's a round circle, it is going to stay a round circle unless you decide to beat it into dust. So they have a fixed shape. A brick is in a brick shape. A pyramid is in a pyramid shape. These are things that are very fixed shapes. They also have fixed volume. So if you were to take a 15 milligram cube of stone and you decided to hammer it into dust, if you were to collect all that dust, it would still have the same volume. It would still have that 15 milligrams of stone. It would just change the way that it is shaped. But again, it would still have a fixed shape because in order for you to get it into dust, you really had to work on it. Particles are tightly packed, usually in a regular shape. So if you take a look at this picture, this is a picture of what the molecules would look like within a solid. If you look, all of these molecules are tightly packed together. We have a specific shape. We have where they are in specific rows and columns. The fact that they have this regular shape and that they are tightly packed means that it is more rigid and it will have the same volume for that object. So with it being in such a tight packed molecules, the molecules barely move. Examples: ice, diamonds, gold. All of these are examples of solids. If you need to pause, go ahead and pause. Now we're going to look at plasma. Now, plasma is a little different. So this one can take the form, actually it uses gases and solids. And what it does is, the characteristics is it is not rigid. It's not. It doesn't have a definitive shape to it. There is no shape for it. If you were to take plasma and release it into the universe, it would actually take the form of whatever molecules it would touch. So it doesn't have a fixed shape. And because of that, there is no fixed volume either. Plasma is really unique. What plasma does is it takes the molecules that are within the air or within an element, and it applies electrical charge to it. These electrical charge particles are well separated. They are further apart than even gas, with no regular arrangement. So its particles are far, far apart, even more so than gas. Examples would be lightning. Lightning is electrical charged particles through the atmosphere. Stars, even our own sun, is made up of plasma. And then the lights that are overhead that give you lights within a classroom, and some of your homes have it, fluorescent lights, those are also plasma. They take they take glass with a powder coating on it, and they put an electrical charge through it, and that's what makes fluorescent lights. So these are the four types of four states of matter, and then we're going to start talking about physical and chemical changes. If you need to pause this, go right ahead, but there are 3 questions out in Google Classroom. It's called States of Matter, and it is questions 15, 16, and 17. Please make sure you complete those questions by the end of class.